All right, today we're talking about 7.4 slope intercept form. Okay, so we've already talked about how a line has a slope. If you're imagining a person walking on the line and always going forward, this is going to be a positive slope. Here the person's going downhill, it's going to be a negative slope. Here the person is going easy on flat land, and the slope represented as m equals 0. And then a vertical line, poor guy has fallen off entirely, and the slope is undefined. So today we're going to talk about intercepts of a line. And if you think of an intercept, something's been intercepted, they've crossed paths, okay? So the intercept of a line is simply where the line has crossed an axis. So we have two axes in the Cartesian plane, the x-axis and the y-axis. And the line, when it crosses the x-axis, would be called its x-intercept. And when it crosses the y-axis, would be called its y-intercept. An intercept is represented as an ordered pair. So this line A right here, it intersects or intercepts the x-axis at -4. Well, when it's at -4, that's its x value. What's its y value? The y value would have to be 0. You haven't gone up any or down any. So the y value is 0. So the x-intercept is going to be represented as an ordered pair -4, 0. The y-intercept would be represented here as 1, 2, 3, 4, 5, 6. It crosses the y-axis at 6. And you're not going left or right at that point. So, I'm sorry, I put the 6 as the first number. You're not going left or right. So our x value is 0. Then we went up 6. So our y value is 6. Our y-intercept is 0, 6. The y-intercept here, y-intercept for line B right here, well, it's crossing the y-axis at 0. And the x value is also 0. We haven't gone left or right. We haven't gone up or down. The x-intercept of this line B is also 0, 0. For this line D is a horizontal line, which will obviously never cross the x-axis. So it would not have an x-intercept, but it would have a y-intercept. And the y-intercept would be where it crosses the y-axis at 0, because that's the value for x, and then -1, 2, 3, 4. -4, because I've gone down on the y-axis from the origin. And then finally for line C here, this is a vertical line. The vertical line will never cross the y-axis, so it does not have a y-intercept, but it does have an x-intercept because it crosses the x-axis here. So it crosses the x-axis at 1, 2, 3, 4, 5, 6. And then the y value is 0. So 6, 0 is its x-intercept. That's where it crossed the x-axis. All right, you can represent a straight line as an equation, a linear equation. We've already talked about that. And one of the most common linear equation forms is the slope-intercept form, which is y equals mx plus b. And where have you seen m before? Over here, where we were talking about the slope. So in the slope-intercept form, you're flat out told what the slope is. M is the slope. B, right here, that value that you'll see in that equation is the value of y at the y-intercept. So here, mx plus b, that b would be 6. It crossed the y-axis at 6. Here it would be 0. It crossed the y-axis at 0. Here it wouldn't have a intercept. And here it would be -4. All right, so with that last one right there, we would see that it would be -4. So we would think, oh, well, then we're going to have mx minus b. If you get confused with this idea, don't forget that this subtraction can be rewritten like this: mx plus -b. So suddenly you get back to this form. So if you ever see mx minus b, if you ever see it in that minus form, you need to keep that negative sign with the y value for the y-intercept. Graphing from the slope-intercept. Here we have two equations, y equals 3x plus 1. So if we're going to graph and we're just given this equation, and you're asked to graph that line from the slope-intercept form, you can actually very easily do it. You find the slope, which is 3, and remember, slope equals rise over run. Another way to think of it is slope equals change in y over change in x. And how do you calculate that change in? You do it by finding two easily identifiable points on a line and go y2 minus y1 over x2 minus x1. All right. So that was a quick review of that. We'll need that for these equations, these examples that we're about to do. So y equals 3x plus 1. We have our slope, which is 3. You can rewrite that as 3 over 1 to get our rise over run. And then y-intercept is that mx plus b. mx plus b. The b value there is 1. So you come over here to graph it, and we're going to intercept the y-axis at 1. So you put a dot there. And now you need to put another dot. Remember, you need 2 dots. Any line will go through 2 dots. You can add 3 dots for accuracy, but 2 dots is sufficient. So our 3 slope is going to be rise of 3, 1, 2, 3, over our run, which is the x value of 1. And we could do it again, 1, 2, 3, 1, and then do our best to connect those lines. I'm not going to get the ruler out right now. It's not exactly straight, but the line would look something like that. All right, for this example, y equals 1/4 x minus 1. Our slope is that coefficient of x, 1/4. And our y-intercept is -2. Don't forget this part. If you have that negative sign, it needs to stay with that constant. -2. That's our y-intercept. So our y-intercept is -2. X value would be 0. We're going to go down to -2. And then we have a slope. I'm going to erase some of this. We have a slope of +1 rise, and then +4 run. 1, 2, 3, 4. And that one, I should have done this for the other one, but I'm just going to get the ruler out and do it. And that becomes our line. So it's actually very easy to do these. If you don't understand that, rewind it, rewatch, come to me. It's up to you. But now let's write the equation from a graph. If we have, let's look at line A right here. You're going to write the equation from the graph. So you find 2 points that are easily identifiable, and it crosses it. This point is easily identifiable, not -4, 0, and this point is easily identifiable, 0, 6. -4. Remember, it's y2 minus y1, so this is going to be our second values, y2. Y2 has a value of point 1 is -4, 0. Point 2 is 0, 6. So y2 has a value of 6, and y1 has a value of 0, so 6 minus 0. Now we need our change in x. x2 has a value of 0, and x1 has a value of -4. So we need to go 0 minus a -4. Minus a -4, which means I'm going to plus it. 6/4. Which reduces to 3/2. So that just calculated our slope. Now we want to take this line and create this equation. We just calculated our slope, which is 3/2. Now, where did it intersect the y-axis? It intersected at this point, 0, 6. And what is the y value? 6. So our y-intercept y value is 6. So now we can plug all of this into our equation, y equals mx plus b. We'd say y equals our slope, the m is slope, 3/2 x plus b, 6. And then we get our equation. Make sure that you keep track of the sign on that constant. If you were writing the slope intercept for this, it would be a minus. -4. All right, that's it. Good luck.